This is your 2.1.5 notes for Module 2. Topic is similarity. For this topic, this is the last section. We did 2.1.1, 2.1.2, and then 2.1.5. Our learning target is I can use similar triangles to write proportions to solve for missing side of similar triangles. Our example is, given that triangle ABC is similar to triangle DEF, find the measure of the missing sides for each triangle. So we're going to try to find this side here, AB, and we're going to try to find this side here, EF. So the first thing is we have to match up the corresponding sides and see if we can get a ratio of similarity between the two. If I look at this side here, it's between the 85 and the 55. It corresponds to this side over here, okay, the 6, which is between the 85 and the 55. Now the problem is I can't write a ratio with an unknown. So I can't use my ratio of similarity from those sides. So then if I take a look at BC, I have 38. It's between the 40 and the 55. Here's my 40 and the 55, so it corresponds with this side here. But again, that side I don't have a value, so I can't have a ratio of similarity there. So what we're going to end up using is the last corresponding side here. If you look at AC, AC is between the 85-degree angle and the 40-degree angle. Okay, and that matches up here. AC matches up with DF, right? Matches up with the 85 and the 40-degree angle. So now you see this side, we do have a ratio of similarity. It's large over small. It's 24 to 8, which I can reduce down to 3 over 1. Or it's 8 over 24, if I go small over large, which will reduce down to 1/3. So I'm going to use this to write a proportion to find the missing side. We can only do one at a time, right? So when you do a proportion, you set two ratios equal to each other. So we're going to take the 24 over 8 equals, and then the side I'm trying to find here is AB. This is from the big triangle, so this is going to be my unknown. I'm going to call it X over the corresponding side here, which is 6. Okay? Now, I could simplify this to 3 over 1, make my math easier, but for fun, we have a calculator here. Let's just do the hard way here. So we're going to go 8 times X is 8X. I say hard way, but actually I can save myself from making a mistake if I simplify this the wrong way. Let's say you simplify it down to 4 over 1. You'd make a mistake. So I'm going to save a potential mistake in simplifying here. So I get 8X equals, and then we're going to go 24 times 6. Handy dandy calculator, 24 times 6, 144. And then I'm going to divide both sides by 8. So I divide by 8, and I get X equals 18. Now don't just mindlessly take the number and say that's your answer. Think about your answer. Does it make sense? So 18, should the side we're trying to find is this side here, right? 18, we're saying this is 18. Should this be larger than 6? Yeah, it's from the bigger triangle. It should be larger. Now, does that ratio sound right? 18 to 6, oh yeah, it's 3 to 1. So it has the same ratio, which it should have. All right, so it works. Now we're going to try to find the missing side. This side here, I'm going to call this side Z. All right, so I'm going to use that same ratio of similarity, 24 to 8. So we're going to go 24 is to 8 as 38 is to Z. Okay? So again, big over small, big over small. We're going to cross multiply. I get 24Z equals 8 times 38. 304. Okay, I divide both sides by 24. And I get 12.67. So Z equals 12.67. Again, let's do some number sense here. Does that make sense? Should it be smaller than 38? Yes, it should be smaller. Is that ratio of similarity about 3 to 1? Yeah, if I go 3 times 12.67, that gives me 38. So I got it right. So, for example, if you accidentally put Z over 38, you would end up getting Z is a huge number, right? And so when you get that number, you go, wait a minute, how could this be larger than 38? You could catch your mistake. You go, oh, I set it up backwards, right? So if you had put z over 38, you would have got a real large number, and you could catch your mistake. All right. Now, we also use this a lot of times for application problems, a lot of times word problems. Sometimes they give you a picture or a diagram. Sometimes they expect you to come up with your own picture or diagram. So it depends on the situation. Here's our example. We have a large flagpole here, and we have an office building. And we have, was it Marquez? Marquez is, realized he's looking up from the ground, and as he looks up to the ground, he can see the top of the flagpole, and he can see the very top of the building at the same time. So this angle here, as he looks up, is the same for both triangles. And then we're going to make one assumption in these types of problems. We're going to assume that the ground is horizontal, perfectly horizontal and flat. And we're going to assume that our flagpole in our building is perpendicular to the ground, straight up and down. So we have a right angle here and a right angle here. So we have angle, triangle similarity, right? This angle and right angle, this angle and the right angle of the big triangle. All right, so now we got to think about what's my ratio of similarity, what sides can I use? Well, I can use the base for both of them. The base is 60. Now you got to be careful. On this problem, you see how they have this going from here to here? They're saying that 170 is that. Sometimes they'll put the 170 in here, and in that case, you'd have to go 170 plus 60 to get the base of the big triangle. But in this case, it made it easy for us. It's just 170. So 60 is the 170. Okay, so I went small over big. So then I'm going to go the flagpole height, 35, over the height of the building. Okay? Again, just got to be consistent. Small over large, small over large. All right, now I could have reduced this, make math easier, but again, calculators nowadays, it doesn't really matter. It's just an extra, extra input button. That's about it. So I cross multiply. I get 60h equals, and I go 170 times 35, 5,950. Divide both sides by 60, and I get 99.17. 99.17 for round. They're not feet, these are meters. Use the right unit of measurement. So 99, a little over 99 meters is how high the building is. Does that make sense? Should it be bigger than the flagpole? Yes. Again, if I would have made a mistake and I put H on top, 35 on the bottom, I would have got a number that was really small. It would have been smaller than 35, and I went, wait a minute, that doesn't make sense. The building's got to be taller. So this ends this topic on similarity. We'll be practicing these problems a lot over the next few days. Thanks. Have a great day.